this video, we'll be discussing about the concept of logic gates and see some basic gates. In this video tutorial, we'll learn the concept of logic gates, we'll understand what exactly logic gates are, and we'll see the 4 different types of logic gates. That is the OR gate, AND gate, NOT gate, and XOR gate or XOR gate. So let's start with understanding what exactly logic gates are. Logic gates are basic building blocks of any digital system or circuit. So they are basically digital circuits or electronic circuits which have one or more input but only one output. Now there is a certain relationship between the input and output, and depending on that, we categorize them in types of logic gates which we just discussed before. Now there are 3 basic gates, that is AND, OR and NOT gate, and we'll also discuss the XOR gate which does not fall under the basic category, but still it is a very important logic gate. So here's a pictorial description. As you can see, it's a transistor NOT gate. We have resistance as well as the transistor TR1 in the center. You can also see the LED glowing. So when the input is 0, the LED glows. Since this is a NOT gate, the LED glows only when the input value is low. So similarly, other logic gates have similar circuit designs.
This is the NOT gate. This is the OR gate. This is the AND gate. And together they are the Logic Gate Squad! Wait a minute. What do they actually do? Well, when engineers design circuits, they need to have a way to explain the behavior of the circuit. For example, if we tell a circuit designed to calculate to add 4 and 7, we expect to get an 11. And if we add 2 and 3, 11 isn't such a good answer anymore. We need to get a 5. And that is the behavior of the circuit. We describe the behavior using logic gates. A logic gate only works with Boolean values. This makes sense since we know computers work with ones and zeros, or electrical current and no electrical current, on and off, which is like true and false in this case. Some values enter a gate. We call those inputs. One value exits. We call that the output. The output is affected by the inputs depending on the gate's behavior. We describe this behavior in a truth table. This is a NOT gate. It has one input, and the output, as the name suggests, is the opposite of the input. The output is not the input. We'll mark the input A. If A is 1 or on, then not A is 0 or off. If A is 0, then not A is 1. This is the OR gate. This time we have 2 inputs, A and B. And the behavior of the output, called A or B, checks if either one of the inputs is 1. So if A is 1, if B is 1, or both are 1, the output is 1. If both are 0, then so is the output. This is the AND gate. The output, A and B, is 1 if both inputs are 1. Any one of them or both is 0 and the output is 0. Now with these gates, an engineer can design very complicated behaviors like taking as input 2 binary numbers and outputting their added value. However, while these 3 are the basic logic gates, we have a few more gates and their symbols that we can use. The NOR is a NOT OR combination. The NAND is a NOT AND combination. The XOR is often called mutually exclusive and will output 1 whenever the inputs are different, 0, 1 or 1, 0, and 0 whenever they are the same. Interestingly, you can use just one gate, like a NOR or a NAND, to replicate the behavior of the 3 basic gates, and consequently all other gates. Now that you know a little bit about the Logic Gate Squad and their friends in the Logic Gate League, It's time for you to try them yourself and explore their superpowers.